We are recording now. Welcome to the evening of Python coding. We have Alan Childress, who's gonna go and talk about one more plotting library with Python. It's actually more than just a plotting library. It's just an environment for generating very, very interesting interactive graphics with Python. So instead of me talking about it and presenting Alan will present himself and tell you a few things about himself, but he's going to talk about Plotly mostly. Go ahead, Alan.
All right, very good. Glad to see everybody here this evening. I've enjoyed coming to these meetups for about 2 years now, and I've learned quite a bit, so glad that I can contribute. We presented this back in January, and this will be sort of a condensed version of what we covered in January. As background, I've been working in AI for about 30 years along with automation, and I got interested in Python about a year ago. I've worked on expert systems primarily. These days I work on a language called Blue Prism for the Federal Reserve Bank, and we're using automation in a lot of ways and also looking to use Plotly. Sorry, to use Python. So I've posted the link in the chat for the GitHub for this evening, and I've started simply with a couple of demos from Plotly. I mean, they've got a really nice page, and so there's a whole spectrum of different things that you can do with Plotly, and I grabbed about 4 this evening that we can look at and look in more detail. But it makes it very easy. Here's your Jupyter widgets that Ellie was talking about, and somebody was talking about. And okay, so we'll dive on into the demo. I grabbed the demo code from these 2 locations and brought them together. And so the first thing we're going to look at is the one that I like for multidimensional analysis.
You might want to share your screen first.
Oh, I'm sorry.
No, that's okay.
Yep. Did we get it?
Yeah. And now we see a nice
Have you got a graph on the screen?
Yeah.
Okay. All right, very good. So we're going to go through the 4 different calls here that make this happen. I really like these parallel coordinate plots because they're multidimensional. And so a complicated thing, this is the classic iris data set. And so you can look at the petal width, the species.
Tell them what is the iris data set first, because some people here don't even know what it is.
Right, so I don't know a great deal of history on it, but it's been around for a long time, and a lot of folks use it as demo. It's a collection of irises and the metrics about those flowers. Here is another one, a different set. Plotly is very nice because it has built-in features that can just animate things and do all sorts of different settings. We'll go into some more details on that, but this is all built into Plotly. And so without much effort, we can present it. And so the first thing you do with Python is you do your import, right? So you'll import your library, and then you give it an alias, in this case for Plotly Express. I also brought in time so that I could track how long it took to calculate, right? So I calculated start time, I calculate an end time, and then I plot it, and that's what comes down here in my debug window to let me know that it took 1.5 seconds to calculate all of this. It goes out and it grabs the data set, and then we tell it that we're going to do a parallel coordinates data set.
Can you press Control scroll mouse, like make it a little bit bigger, Control zoom?
Oh,
like Control scroll mouse zoom, or I don't know, whatever the zooming, to make the font a little bit bigger because people are asking.
Yeah, I'm sorry. This is PyCharm, which I'm a big fan of.
Yeah, so you do Control, I believe, press Control and with the mouse scrolly button.
Yeah, I tried it. That's not working.
It should.
As we say, also a reminder, you can change your layout so that this is on Spotlight, so it takes up as much space as possible. It'll give you the biggest image.
Yeah, does somebody know an alternative set of commands to zoom?
It should do the zoom thing, but if we cannot find it, just continue, because usually the controls scrolly wheel thingy does this.
You know, there should be like a zoom. Is it view? Sorry.
No, that's fine.
Okay. Well, anyway, so you pass it in the various attributes that you want to present, and then you may do things like updating the layout by giving it a title. I added that past the demo code.
Hey, Silas had a suggestion that you might want to try. It's in the chat.
That's what you would need to do on the viewers end to make sure that the presentation is blown up to be the biggest
I
portion.
could change the display settings, but that may have drastic effects while I'm demoing right now. So,
yeah, if you're following, make sure to follow the instructions I put in the chat for viewing.
So the good news is that, you know, with a very short amount of code, you can produce the graph that we were looking at, right? That has all the automatic information. And just to give a different one. This one goes a little bit further. I used Pandas, and that
for people who don't know what Pandas is, can you explain in a few words what it does? Because we're beginners here.
It's basically a very large spreadsheet, and so it's about handling and manipulating data in very powerful ways. And so there's a thing called a data frame. Anyway, it makes it. In this case, we did a very easy read of a CSV file off of the web, and with the demo data that they had, and then we created a figure. So we allocate fig, and so GO we've defined as our graphic objects. So we do our graphic objects, and we do a figure, and then we can apply, in this case, the parallel coordinate data, and then we supply the various attributes that we need for that.
Yeah, there's a question about what kind of data we're working with.
This was a CSV file in this case, and
can you show it just
yep.
So people can.
So this is engine information, I believe, and so we have block material, cylinder material, block width, block height, width, etc. And so, again, in the same way, you can change up and zoom in on things, take a picture. This one is fairly simple. I'll show a more advanced one in a little bit. So, a key thing about Plotly is that you're supplying the information as dictionaries. So, dictionaries are variable value pairs that have keys, and it's very rich. So, you can pass in basically anything. And you can pass in dictionaries of dictionaries, lists of dictionaries, etc., which is basically what this is. So it's basically a whole series of instructions to Plotly as to how you want to present the data. And then we do an update layout command and update the title, and then the important show command. And that show command...
What does the update layout do?
There's a basic layout that's been calculated, and then we're going to modify it by adding a title. So that's what the update layout does in that case.
So layout represents what is going to be displayed eventually, or like title, axis, how many figures, things like that?
Right. Let me go share mine. I'll jump ahead for a little.
I also have another question about what type of data this is, like health versus species data. And a question about how you...
Oh, the iris data was just metrics in terms of the size and color and such of the irises, and what was presented. This, you can concentrate it down so that you're just having one line to pass in the figure, the title of the data that you're going to present, you know, the x-axis, which in my case is the date, and the y-axis, which is the Bollinger Band upper band, and what color you're going to use, etc. So these are the kind of things that you can pass in to your Plotly to get it to prepare. And So you get it all put together as a layout, and then once you're done, after the fact, you can go modify that layout to add additional features. I'm going to tell you what, let me go to the fourth demo. Is it this one? So this is 3 graphs all together, and you can do that. You can tell it basically that you've got 2 rows and 2 columns, but then you split this one across 2 of those rows, and so you have 3 graphs that you bring together. And it does the cool stuff like it'll animate, and you can turn information on and off. But this is volcano data plotted on the map. And so this is our subplot 2. We went and used the data frame to go read a CSV file of all the volcano CSV data off the web. And then we went and we calculated frequencies. Using that data frame, we did a count on the frequencies, and that's how we produced the second graph. And then we read another CSV file in, and then we initialize it. So this is the important thing. We make a subplot graph. We define the number of rows, which is 2, the number of columns, which is 2.
Alan, maybe it will be easier. Can you actually bring the CSV file and open it in the spreadsheet just to show people how it looks like? Because I believe most of the questions they ask what kind of data, how it looks like. So the CSV file is basically a spreadsheet.
A common separated value, yeah.
So just show them the raw data and show them the result eventually. Bingo.
So this is the raw data here, and as you can see, it is numeric, but it is comma separated, right? And so you're labeling basically the volcano numbers here on the first row, and then certain dimensions on the next row, etc., right? And so that's how all that information, and so you bring this into a data frame, and then you can easily manipulate it within the data frame. Does that answer the question?
The data frame basically takes the columns out of this and makes it into a table that it stores inside. This is what a data frame is, like a glorious table. Very sophisticated table that you can ask questions about.
Right, and you can aggregate the data and that kind of stuff, right? And so it's the aggregated data that we pass into Plotly, and then Plotly graphs it. So we told it that we had 2 rows and 2 columns, and the row height, and then we span it across to present it. And so this add trace adds the scatter geographic information. So this is the real workhorse right here within Plotly that is presenting that globe, and it gets the latitude and longitude data out of it, and then plots that information on the screen. So again.
So where was the longitude and latitude? It was like two of the first columns or something like this in the data?
Yeah, I'm not sure how it knows which ones are the column names, because I didn't see column names in the raw data.
We can look at it again. Right. Can you show the CSV file again?
Yep.
So this is the data.
Let's see the column names.
So I see V1, V2 up until V something. This is the first line. Typically the first line is the data itself.
Or the column there, right?
The names of whatever it is, usually. Now, can you scroll down just to make sure maybe we didn't...
Yep, I don't.
Yeah, maybe we'll try some... So the question is, how does it compute that?
Right, I guess we could go look at, let's see if we can find the iris data.
Yeah, the iris is easier. Iris has the coordinates and everything inside this.
Oh, it's built in though. Yeah, I don't know how to go get that, sorry. That's built into Plotly Express, is that basic data set.
It's this data set is used in anyone in machine learning. It's been around for a long time, and there are several people who don't like it because of some who created it. But never mind. Now they're using different data sets trying to get rid of this one. But yeah, this is what I heard. One of our speakers in the Python meetup talk was talking about it recently.
So one thing that I did, you know, if every line has a lot of information to it, I created a graphic helper. And so, you know, it imports Plotly, but then I defined my own add trace line because every line was looking like this, right? And so I can take all of this and pass it in as one line and just pass it through to shorten my syntax, basically to refactor it.
For the newcomers, you created a function, and this is how you create a function in Python, by using the def command. And your function takes variables and then does the things that look the same always.
Right, thank you. So we pass in all of these possible, and the cool thing about Python is it can default, right? So if I don't pass in a line mode, it assumes that the line mode is lines. If I don't pass in a line axis, it assumes that the y2 is the value, right? So I can choose to just pass in the information that I need and everything else is defaulted, but I can custom override. And so then my code
becomes shorter.
Right, becomes shorter and a whole lot easier to read, right? And so instead of multiple lines for each one, it all gets passed in. And again, there are individual customizations that get passed in that override those defaults. And so that's how I can then present this data. And so this one's a little bit more advanced, but I like it because you can see some more of Plotly's features that are built in. So here it's showing the individual data, but I can turn on so that I'm showing all of the individual data components throughout. You can turn legend items on and off so we can get a very simple graph. Here's just purely the candlesticks, and then we can add the Bollinger and the MACD and add stuff back in. But the other thing that's nice is that it has built in to be able to zoom in. So I can select a certain section of the data and it zooms in, and we can zoom in even further. And if you get lost, then you just hit the home button and you go back to where you came from. I defined various buttons that I passed into the figure so that I can zoom in to 6 month, year to date, 1 year, etc., or back to all. And so, you know, it's really powerful. And to go back to their webpage, you know, you've even got your AI machine learning, drawing rectangles, using Dash. You can do scatter plots. You know, basically anything that you can think of, they've already done it, and then all you need to do is take your data and plug it in.
So in a sense, Plotly is advanced in the sense that it allows you to create those nice figures that are interactive, correct?
Right. So we probably can grab just any one of these. And it also is nice on their page because they show you the data. That's what I grabbed, and so then you can see the animation and all those kind of things. By default, when you do a show, it's going to show up in your web browser at the home address 127.0.0 and on the different ports. So that's how it just by default presents it. What I do is I take mine and I save it to a file, and then I can use Qt graphics to present that. So this is actually a standalone window. It's reading it. This is an HTML file that it read. We produced it with Plotly and then had Qt contain that graph. But still, all these great Plotly features are still present, even though it's within it. I can shift over to be able to drag it. Let's see. And so, oh, and another thing that I've done is I've synchronized the upper graph and the lower graph. So here is 2 rows and 1 column, but I told it to synchronize. So when I drag one, then it drags the other graph, right? So that's, you can sort of get in there and figure out the different features that you would like to add.
Let's go back to the demo. Show us the code, so people will understand how you generate this.
Okay. So here is an update of the axes. I take out, because it's stock trading data, I don't want Saturday or Sunday, so I can use an update axes command to remove that data. Otherwise, there would be holes missing every weekend. Here's again the example of the update layout. So I set the title, and I have my particular stock ticker variable, and so I concatenate that together so it says the total string of stock price analysis for Tesla. And then I can change background colors. Here's the legends that I set up, and you pass that in as a dictionary. Again, the dictionary is variable value pairs of instructions.
Dictionary for the people who are newcomers. What's a dictionary basically? Like an example?
That's what I'm saying. Variable value pairs. What would be? I mean, if you open if you open a dictionary itself, you find an individual word, and then the word has a definition, right? So the word is the variable, and the definition is the value of that, the more detailed information, right? So that's why they call it a dictionary, and you can look it up, right? You can look up the word for alpha, and go find it, and then you can, aircraft, right? You go find the word aircraft, and you find the definition of aircraft, but it does the lookup. So that's a built-in feature of dictionary. And so
with this legend, the orientation is the key and the value is H, correct?
Right. The orientation being horizontal in that case, right? That they offered. It's a series of, here's the variable. The variable is called orientation, and the value is H, or the Y anchor, and the value is bottom, right?
And those are called keys. The variables are the keys, because they're the key to the dictionary.
So here's more update layout information, adding ranges to the slider with buttons. In Python, it's always a good idea to comment your code so that you can explain it to others as well as yourself when you haven't been in it in months. One of the things I like is that I can include a URL to particular things, and that's a great way to then cross-reference back to what it is that, why you added that information. The colors that I have are Fibonacci colors. And so that's sort of what is the Neapolitan ice cream kind of look here. Those are actually meaningful values, and we know from that humans tend to trade on these numbers. You'll notice it sort of bounces off of these numbers, that humans trade off of that. So that I'm able to easily go calculate those. And that's what ends up being here. There's a nice table command. And so the values that are calculated, I get to see in my debug window.
And when you get a chance, does an update layout create a dictionary?
I don't remember. Where did you see update layout? Oh, okay, sorry. No, an update layout consumes a dictionary. It gets its instructions in the form of a dictionary, and so you prepare that dictionary in the standard format and then pass it in, and it receives that dictionary and follows those instructions. Did that answer your question?
So think about the dictionary as values, like let's say title or axis title or stuff like that, and the layout will get all those parameters from the dictionary. By the way, this is very much for people who do Python. This is very much like Python, except say variables in a function. It kind of like is a dictionary. So it's kind of natural for Python. Think about it. It's like you're saying all the things you want to say to the function in the dictionary, all the variables, and you just pass it the dictionary.
Let me walk up from, if we start from a simple variable has only one value in it, and you have the label of the variable, right? The next step up would be a list. And so a list may have multiple values in it, but they're all of the same information, a list of groceries, for example, right? The advantage of a dictionary is it is a list, but now it's 2 columns, right? It is, one of the columns is the variable itself. So imagine a grocery list, and you had bananas and then you had the price, right? So item would be your key and dollar amount would be your value. So then you'd have apples, 53 cents, bananas, 83 cents. Paper towel, 275, right? So that's a dictionary that you define. It's bigger than a regular simple variable and better than a list. And it has the advantage that you can pop in there and you can say, how much are paper towels? And it'll hand you back that value. And that's the power of having a dictionary.
And then you have the function that says, buy all my groceries, and you just pass it the dictionary, and it knows to, the function knows to add those up, basically.
Right. And it knows you've added substitutions in as a column, and it knows whether to do substitutions, etc. I'm fairly certain our local HEB probably uses Python in the background to do their user interface on things. We don't. Okay, so that's the basics. I'm happy to continue to take questions. If I didn't explain it well enough, we can try and get a bit more detail.
I have a question. Can you go back to the iris example and just go line by line very slowly, because you were trying to answer all the questions, but go back to one example and just line by line, it makes it easier.
Right, okay. So by the way, with Python, I have these sub functions and I need to include them. So I say, from this particular file, import this function. I happen to name it the same thing for ease of use, but they could say different things, right? In PyCharm, I'm able to hit Control B and go in and look inside. So then specifically, we imported Plotly Express, and then I additionally imported time so that I could do these time calculations. We create the data frame df using the base Plotly Express that we had, and they have a data library, and then specifically in the data library, they go get iris and rearrange it, and it doesn't need any arguments. That just hands back a whole data frame.
Can you just make it easier, after the word df, just add another line after df, say df.describe, just so it will be just another line, df.describe. This will show you, and close and open parentheses. This should, when you run it, it should now show in the bottom what the data set looks like, or some of it. It will describe to you what's going on. It should put it in the output in the PyCharm when you calculated it.
I did not see. Do we need to do a print on the describe?
No, it should do this on its own.
Didn't seem to. It took it an extra second longer, but
it should. Yeah, just open an immediate window, just bringing the data set, and we'll do it, and then it should work. You know what? We can do it later. We can do it later. For now, because I want people to actually see how the data set looks like. But the describe should.
There you go.
So.
Oh, sorry. Let me get it quick. So there, a print of it gives this information. That's your data set.
So this is the statistics of the data set, but this is the data set has petal length, sepal length, petal width, and species ID, which is a number which tells you whether each species, whether you are this type of iris or that type of iris. And you can see the values, if it's not the actual data set, but you can see actually
which is what describe does. That's a nice thing. Yeah.
Those are the statistics of this data set. Where the CSV file is much larger. But
yeah, I suppose we could print DF and no telling what kind of results we might get. Do we see how many rows? Count.
What's the command for? What's the command? Is it head that'll do like the first 10 lines or so?
It's only 150 lines, so I think we can suffer it. Let's see what we get.
I think head will do it, but I'm not sure.
Also, when you get a chance, somebody's asking what parallel coordinates is.
Here we go. This is how the data looks like.
This is an example of parallel coordinates. And so if you imagine, if you only have 2 dimensions, it's easy to plot that information, right? But imagine you have 15 dimensions, right? It gets hard to comprehend, but this is a clever way to do it. So on a given axis, you plot along it, and then you plot the other, what would be a whole nother graph, right? But then it connects one instance is the connected line across these, but you can see sort of the trends in your data. And the thing that I like is you can sort of cluster it until you get it similar, and then you may infer things about your data by the order. And sometimes you may realize that you need to sort it in an opposite order. So that's the advantage of what this parallel coordinate technique is. Even Excel has it these days. And it's really good in machine learning for looking at, if you have, 10 or 15 input sets, you can present it and get an essence of what your data is about. Does that answer the question?
Can you go back to the example, the iris example? Let's continue it. So now
Yep.
we know how the data set looks like. It looks like this. You can actually go back and see petal left, center left, and it's long.
Mm-hmm.
And this is the table. But now what you do is you create the parallel coordinates. And what did you do there? Well, what's colored equals species ID. What does it mean?
Apparently there is a color that's named that. I don't know.
You took the species ID column, and the numbers there are 1, 2, or 3 because there are 3 types of irises.
Yeah, that's what it did. You're right. I get it. Right. So we took this column here, and then we use that as a color. And so if we go back to the data, so these simple number of colors, we have about 3 different colors, but each one of those colors, 1, 2, 3, which we get R, G, and B, well, yellow. So that's what they chose to assign. The color was using that column. Okay. And so then we also had labels that we can see here: sepal length, sepal width, petal length, petal width, species. And so we had defined those here and passed those in as it's a list. The curly brackets.
It's actually a dictionary on itself. It
Is
tells
it?
you what to map to what. So species ID, it becomes species because you don't say species ID. Whatever the column species ID's ahead now will be under the title species. Because you don't say species ID anymore, you say species.
So it's a pair. It's a set of pairs of variables and values separated by a colon. And so then you have multiples of those, and that's how we then create. It then creates the different titles.
Yeah.
And so, go ahead.
No, the continuation is very simple, but then again, there's something like px.colors diverging t/rows. Where does it come from? This is from Plotly.
I don't see what you're talking about. I'm sorry.
No, color continuous scale. What you're highlighting now.
Okay.
It says
All right.
px.colors diverging t.rows. So.
Okay. So in that case, Plotly Express is our base. It has a color library, and apparently there's a subcategory of it called diverging, and then there's a specific value called teal rows. I wonder if the control B would get us there. It might.
This is a color map. This is how the colors will be mapped, and you can choose something else, I assume.
It got me in here, but I don't see anything of interest. Okay.
We have another question about how you go from 16 columns to the 6 values that you see in the graph.
16. Oh, okay. So what you mean is, okay, this data to what we see in the graph?
Time to Speak Now is asking the question. If you can follow up in the chat.
I would think that what they're asking is, how do you go from all the data that's there to what we see? Each column of data.
I think he's talking
in a
about
parallel.
he's talking about the other CSV that had more columns.
Okay, this one.
The one you showed with the header rows like V1, V2.
I think they're talking about the raw data.
Yeah,
The raw
one
data
is the
CSV.
volcanoes.
The volcanoes.
Yeah, but
it ends up
volcanoes,
looking like this. Okay, and so then we ended up, it did a count by country, and so then it did a plot of that from there. I can't answer how you go from V1 into those different columns. I did not see anything obvious. We can go look in more detail
We can
on
look at
that.
the code.
It's the fourth one. So, yeah, this one. So here's our longitude, latitude, but we'd all like to know, how did they figure out that in the data frame, how did it label it as longitude? It must have already been done before this point.
No, so there's a scatter geo thing. Add trace. What is go.scatter geo?
Well, so geo is the graphic objects of plotly, right? And so within that is a scatter geo, and this is what creates the globe. And so then we pass it this information that the globe graph needs to present the information. And it has a latitude and longitude, and it goes into the data frame and gets the latitude data column out of it. But I don't know how we took that CSV and managed to...
No, but the data frame is actually defined well before. Whatever the CSV is not the data frame you're using. This is, the first one is the data frame. The volcano database, you're showing the wrong file.
Okay.
Like if you look at this, you'll probably find the longitude and latitude.
Whoops, gotta put it there. Okay, that's better. Hey!
So you were showing the second file, which had the information about the volcanoes.
Yeah, sorry about that.
No, that's okay. This one has longitude and latitude, and now it all makes sense, because those names later you can just use. So
then we can tell it what, and we could have used other things. If they'd been labeled something different, we could have used it. But so that's what we told it, the longitude and latitude variable columns.
Yeah.
And I went ahead and added name in here just to give it a column title on it. And marker, for some reason, has another dictionary, so it has a color, a crimson, size, opacity. The other thing is there was a switch as to whether the legend, they had false by default. I went ahead and made it true just to experiment with it. And it came over here, and so then I changed it. It just said like trace 1 and trace 2. So I changed those over to rename them so that it's more meaningful. But it's useful then I like turning the information on and off. So that's the advantage of having a legend. If you don't have the legend, you can't turn it on and off. So let's see, 3D surface of the volcanoes. Oh, that's a 3D surface graph of the volcano information, right? Which is X, Y, and Z information, right? And so then there's an update. We add additional information to enhance it. There's always a default graph, and then you can enhance it by doing the update command. And so we also update the axis and update the layout with additional information. And then again, the final action is to do the show command, and then that's what sends it to HTML, to the browser by default. In my case, I take it and dump it to a file, and then I use the Qt command to display it as an actual window. Okay. Anything else?
So I would like you showed some examples of what you can do with Plotly. You showed some code that is people hopefully are able to follow it now. I have a question, like how easy it is to learn this library. If you are an absolute beginner, what should be learned, what the users should do, and how easy it is to actually go and do something with the library, and for someone who doesn't know it, and why is it better than, let's say for example, Matplotlib or some other plotting library?
Okay. I have not used the other library, but I've asked that question myself quite a few times of people who have. And basically, Matplotlib is more powerful in that it does more, but it gives you more responsibility. You have to do a lot more. Plotly shields you. It's sort of like having a Cadillac. You can just get into a Cadillac, turn the key over, and go with it. And you don't have to understand all the details of how to make the car work, right? But at some point, if you want to build your own car, then you have a lot more control than you would in a Cadillac. So in Plotly, you can go into a given graph that you're interested in, and they give example code that, and that's what I did is I, cut and paste in, and then you can enhance it from there as I use Google on a regular basis when I need to understand something in greater detail, and then enhance it to do the additional features that I want. So that's how I eventually ended up adding all the things that I did to my graph.
Okay, so specifically for Matplotlib, I can tell you that it's a much older library. You can do a lot with it, but Plotly is much more versatile, and it allows you to create interactive graphics. Very few libraries allow you to do this.
Mm-hmm.
We gave examples of other like Holoviz technologies. By the way, Holoviz can accommodate Plotly plots. You can actually go and do this, but the idea is that those are the new generation of plotting libraries where you can interact with. The things that Alan was showing you where you drag things did not exist in older libraries that you couldn't interact with.
Yeah, and the plus and minus is, being shielded from it, you don't have to worry about it, but then you don't have as much control over it. So that's sort of but from my perspective, you can start with one, and if you need to, then you can shift over. It can be a bit of a painful process to convert libraries, so better if you can figure out the right one to begin with, but you still can do it. Your basic code is the same, your data is the same, and then you just need to wire it into a different library if you have to.
And how
but
much
I've been
how much time did it take you to learn this library to use it?
Well, I had something working on the first day within an hour, right? I had the basic, if we pare it down.
Perfect answer.
There we go. It's a little slow. But I mean, basically, I had, sorry, it's running slow right now. I got too many things running. I had the basic candlestick, within an hour, and then I knew what I wanted to do, and Bollinger was like the first thing that I added.
So this is stock data, just for people who didn't see it. This is not something that is in the demo code.
Right.
We had some questions from the audience too. If you have a chance. One question was if you can use other than CSV data for input.
Yes, this is live data from TD Ameritrade. I have an API call. So this is today's data that I went and fetched. And I can, fetch 1 minute data when I can change the stock purely from just modifying my configuration.
So for people who ask this question, the data presented at Plotly can come as a data frame. The Pandas data frame, the library that controls the data frame, is called Pandas, and it can read from multiple variations. It can read Excel files, CSV files, it can access SQL databases. It doesn't matter how. It's kind of a library that takes the data and organizes it a certain way that can be later consumed by other libraries. And Alan is using it for the Plotly one.
Yep, I'm trying to walk through my, but roughly what I end up doing is if I can load from CSV, and if I do, then I can go use Pandas to go load my CSV file just for testing. But otherwise, if I'm using the API, then I call into my TD Ameritrade API and can go in and go fetch it, which is really wonderfully straightforward. It uses the REST API, and that's the right. Here we go. Yep, it's just request is a built-in library for REST API, and you get back a JSON control structure, and so then I just take that and do a quick conversion of JSON into the data frame and return the data frame, and then, as we're used to here now, we use Plotly to then present the data.
So think about the data frame as an intermediate before you actually go and do something with the data.
Right, and so that's what I do then, is I have some more advanced, well, there's a nice, easy one-liner command to create the moving average. And so these 14 and some of these lines in here are moving averages. That was one line of Python to do that, and it calculates an additional column. It adds that additional column to the data, which then Plotly immediately recognizes and adds it. As you add another column, it just goes ahead and adds it to the information. I do define how I want it presented, like I want this one with the dots and the dashes, and this one with the green, and that kind of stuff, right? The colors are just rectangles that I draw in the background. I calculate where I want those y-axis to be, and then plot the rectangles. I'm able to add additional rows to the data, and so that's how I predict 3 days into the future. Basically get the moving average and with the first and second derivative, and predict what data is going to look like tomorrow. And so that's an extra row in the data that I add to the data frame, and again, it then presents.
So, unless there are more questions, we need to wrap up at some point.
There's some more questions about if you can, the interactive graphics can be integrated with a website, and what libraries for the TD API call.
If you Google TD Ameritrade API, it'll take you right to it. You need to register with them. You log into your TD Ameritrade account and you get a token. And that token I've used now for the last year. And with that token, then you can get elevated authority. With the token and user ID password, you can actually do trading with your account. In this case, I just go get historical data, so I don't have to do the elevated. And there is another library that you can go bring in that somebody else has. I haven't used it, but it makes it easier for doing actual trading. It's straightforward enough with the historical data. I just copied and pasted the code and modified it. That was that question on what was the web interface. So Plotly by default is using, where did it go? Here we go. This is web, and so it's easy enough to then present it through a web server. It's already in the correct format. This is it actually generates HTML, right? And so then you define a window on your website and can present this, and then it's interactive, right? So your users can actually interact with it. I wish this thing would rotate. It doesn't. I was sad about that, but I went looking and unfortunately couldn't find how to get this thing to rotate. But hopefully that answered the web question.
Another follow-up about whether you can do the active trades via API.
You can. Again, it takes activated. You have, first you get the token, and you include that token, and then you use your user ID password, and you get a second token that's only good for about 30 minutes, and then it expires. So about every 30 minutes you have to go get another fresh token, but that gives you full access to your account to read and write. And I don't know of too many other trading companies that allow that level of access. That's part of the reason why we chose TD Ameritrade. My friend Paul is very wise on this, and I followed his lead on that. But I've enjoyed it. It's been fairly straightforward. After hours, I'll be glad to walk through that code in more detail.
So, unless there are many questions specifically about Plotly, we can talk later about trading and stuff like this. But any more questions about Plotly specifically?
me stick this in the chat for anybody that wants to see it. Okay, well, I'm glad to share. I have lots to learn as well, but if I can help out, I'll be glad to talk about it more.
No, you helped a lot. You explained. You just started using Plotly within an hour and can do those wonderful graphs. And this is what we're here for, so people can understand it's not that complicated. And Python is very powerful. So I would like to thank you for this, and everyone else, please unmute yourself, clap, make some noise.
No, thank you.
Right.
That's very interesting to learn how to, because I am interested in stocks as well, so it's kind of aligned with my kind of view, especially with Python.
Yeah.
So that was very helpful.
Thank you very much. I'm glad to help.
Thank you, Alan, and we're going to stop the recording now. Stick around. We just stopped the recording.